Welcome. This is part 2 in 4.4. And here we're looking at some rational expressions, and you're asking about proper and improper. And thinking about fractions, 2/3 is proper. Improper would be 3/3 or 4/3. And it's the same principle here, except for we're looking at the degree. So degree 1 over degree 2 is proper. 3 over 2 is improper. 2 over 4 is proper. 1 over 1 is improper. And 3 over 1 is improper. Now, on this case, you're writing it in equivalent form. So this is looking at, and it's only if it's improper that you're doing that. So an equivalent form would be division here, and I went ahead and used x plus 3, so negative 3 is the root. Synthetic, an equivalent form would be x minus 1 plus 8 divided by the actual divisor, which is x plus 3. And then you come into some interesting stuff here. So here's another one, x squared plus 5x plus 7. The denominator is x plus 2. Where do you expect the vertical asymptote to be? Well, when x is equal to negative 2, that's when it should be undefined. Okay, intercepts, where would the intercept be? For that, you could plug in a 0 to find the y-intercept, and that would give you 0 plus 0 plus 7 over 0 plus 2. So you would expect it to be at 7/2. Okay, and use some technology to graph the function. And so let me show you what I found. Here's the function. Okay, notice it comes down and then it approaches this value at negative 2, and it comes over here and it approaches this value also at negative 2, and that fits with the x plus 2, right? Because negative 2 is the vertical asymptote. But there's another thing that's interesting on here is there's what's called a diagonal asymptote, or a slant asymptote instead of a horizontal one. And you can see that the expression for that is x plus 3. So let's go back. Okay, so we noticed a slant asymptote at the function equal to x plus 3. And here it is, x plus 3. And then relate the graph of the function to the equivalent expression that you wrote. So another way to look at this would be, what if we were to go ahead and divide the dividend by the divisor? And I'm using the synthetic here. Okay, so the root is negative 2. So negative 2 times 1 is negative 2. That takes us to 3. And negative 2 times 3 is negative 6, and that takes us to 1. So we end up with 1x plus 3, remainder 1. And so what you note is that the quotient, which is x plus 3, is equal to the slant asymptote. And so if we were to generalize, we could say for improper rational functions, the slant asymptote is the quotient. But without the remainder. And that's because this remainder of 1 is not reflected anywhere in that slant asymptote. It's all in this x plus 3. So now we have a strategy that we can use anytime that we have a improper fraction here.